Hi everybody, in this video we're going to practice building spanning trees. As a reminder, a spanning tree is a subgraph of a graph. In our subgraph, we want to keep it connected by including all the vertices and dropping any cycles. So as you're building your spanning tree, remember it needs to touch every vertex, don't leave anything out. Don't include cycles, loops, or parallel edges in your spanning tree, and make sure you have just enough edges. In fact, you'll have one fewer edge than the number of vertices in the graph. So let's start small with a triangle. We have three vertices, A, B, and C, and all three vertices are connected. So three vertices, three edges. Because we're making a spanning tree, we know we only need to have two edges in our graph, so we get to drop one. We have choices in which edge we could drop. We could drop AB, we could drop BC, or we could drop AC. So there are three different spanning trees we can get for our original graph. In all of these graphs, the green line shows I kept the edge and the dashed line shows I dropped the edge. If we make that bigger by forming a square with vertices A, B, C, and D that has outside edges of AB, BC, CD, and DA, and then an inside diagonal edge connecting B to D, we can look at a few spanning trees for this graph as well. Our original graph has 4 vertices and 5 edges. We only need 3 edges in our spanning tree, so we need to drop 2. In my first example, I dropped AD and BD, so the left edge and the diagonal. In my second spanning tree, I dropped AD and BC, so the two vertical sides. In the last example, I kind of made an X with a line on top, and this is a mistake. You can't create this spanning tree. Yes, it's a tree, but it's not a subgraph of our original graph. In our original graph, we didn't have an edge AC, so if that edge is not in the original graph, it can't be in a spanning tree of the graph. As this gets bigger, you'll have more and more spanning trees that you can form. In this example, we can see we have 5 vertices and 9 edges. We only need 4 edges for a spanning tree. So you can go through and look at different edges that you can drop. As you work with spanning trees, remember the goal is to connect all the vertices using only the edges that already exist in the original graph. If you're asked to draw multiple spanning trees, each one can use different edges, but every tree must include all vertices, remain connected, and have no cycles, loops, or parallel edges.